Good morning. My name is Mr. Arnapol. Today we'll be discussing and practicing second semester dosage calculation questions. Let's get started. So the first thing we need to always know is our rounding rules. Whenever we have exams, we will have the rounding rules above each question when we do dosage calculations questions. Here's a few examples of them. With whole numbers, do not include trailing decimals or zeros in an answer. So if the answer is 10 milligrams, the answer is not 10.0 milligrams. And in this one it says 5 or incorrect 5, 5.0, 5.00. The answer would be 5. With decimals, you must include a 0 in the whole number place. So if the answer is 0.25, if you put 0.25, that would be incorrect. It's extremely important for you to get used to this, because if you write this incorrectly and somebody checks your work incorrectly, you could be giving 25 of something instead of 0.25 of something. So we want to make sure that you're used to practicing this. Here's the current rounding rules that we use. And as equations get further into difficulty, there are more rules, including things like heparin that has its own rule. But unit of measures must be identified correctly. But when you're doing a paper exam is the only time that you would actually place the unit of measure, like tablets, milligrams, milliliters, drips per minute, micrograms. Other than that, if you have an online exam, you are only to put the number. Otherwise, it won't be marked correctly. And do not use commas. If it's 1,000, the answer is 1000. No comma in that. Do not round numbers until the final answer, except for weights. Convert all weights from pounds to kilograms. Round weights to the nearest hundredths for calculations prior to completing the dosage calculation. If you have less than 1 mil, round the answer to the hundredths place. So 0.457 rounds to 0.46 and 0.453 rounds to 0.45. If it's greater than 1 milliliter, round to the 10th place. So 2.45 rounds to 2.5. 2.43 rounds to 2.4. Infusions are calculated in drips per minute or mils per hour. Drips per minute is rounded to the whole number, so 21.6 drips per minute. It's very difficult to actually round or to actually see in front of you a 0.6 of a drip, so we round that to 22. Mils per hour is rounded to the whole number as well, so 21.57 mils per hour would become 22. This is specifically for dosage calculations. There are many ways to do this. The big piece that I want you to know with this is that we are doing dimensional analysis. Your books have multiple ways of doing this. Find what works for you, but I will be discussing dimensional analysis. So this is a conversion chart talking about different ways, looking at the actual number line, dealing with kila, heka, deca, uni, deci, centi, milli, and micro. This talks about how each one is off by tens in the charts. So a gram in the middle with that U would be 10 of a decigram, or 100 of the centigrams, or 1,000 of the milligrams, or 1,000,000 of the micrograms. And it works the same for liters as well. But on the bottom, I want you to see this gold. As we move forward, this gold is going to be your key. It reminds you about conversions. I made this chart, I made this PowerPoint to be color-coded to help you find where your numbers are coming from. But if you see gold in this chart, and I'll point it out as well, the point is these are conversions that you already just need to know how to do. Also looking at things like units and milliequivalents, they are a unit of measure, but you don't convert those. So, dimensional analysis. Again, know your conversions, but on the left of the equation, know what you're looking for. Right of the equation is what is available. Find information that matches the measurement in denominator. Cancel until right and left of equation match and solve for x. The idea here, and it'll make more sense as you go forward with this, pause whenever you start seeing these equations and I start going through the answers. It gives you a chance to work on them. And you'll see how I did this with the solving for x moving forward. So the first thing we're going to work on is infusion of IV medication with an IV pump. So right now we have an order to infuse 750 mils of lactated ringers over 8 hours. How many milliliters per hour should the IV pump be programmed to? So I have mils per hour that's necessary. So I have X mils per hour. That's on the left side of the equation. So I will start by moving into what do I have available that is mils per hour in the equation. You can see that the mils is already in the equation at 750, and the hours is already there. So I already was able to put everything into that and just divide it through to be 93.75 mils per hour. And using the rules that we've already placed, it gets rounded to 94 mils per hour. And when you see that red circle, it's like a little happy red circle cloud. That is your answer for this equation. Again, go through these, pause when you see the equation as we move into this next one. Pause here if you wish to try and do this on your own, and then move forward. So the order is to infuse 1 gram of Ansef in 100 ml of normal saline over 40 minutes. At what rate, or mils per hour, will the nurse set the pump? So again, I need mils per hour. So on the left, I have X mils per hour. I will then pull from what I have above to make it mils per hour. What do I have? Well, I do have 100 mils, but I don't have an hour. So I need to convert that into hours. How would I do that? I use those 60 minutes per hour, which allows us to cancel our minutes. This is dimensional analysis. By canceling those minutes out, we have mils on top and hours on the bottom. If that's exactly what you need, that's what it is. At that point, you can go ahead and multiply across and divide. That gives us 6,000 on top and 40 on the bottom, which is 150 mils per hour. Happy little red cloud. Let's do one more. Administering of 1.5 grams of vancomycin over 90 minutes. The vancomycin dissolved in 0.2 liters of D5W. How many milliliters per hour should the IV pump be programmed to deliver? Okay, so again, I need mils per hour. It's just not saying ml per hour. It just specifically states mils per hour, and you'll need to be able to recognize that in a question. Again, on the left side of the equation, we have X mils per hour. What do I have up there? Well, I have the liters and I have minutes. So how am I going to do this? Well, I'm going to pull those liters over, 0.2 liters, and the 90 minutes. That's what I have available to do that. So I need to start converting to get to the mils per hour on the left side. So the first thing I'm going to do is use the bottom. I'm going to knock out those minutes per hour like we did last time. So 60 minutes in an hour allows us to cancel out the minutes on top and bottom. So now I have liters per hour, as you can see, 0.2 liters per 1 hour. But I still need to convert. I need to add another conversion to allow us to get rid of those liters. And if I have 0.2 liters on top, I need those to change to liters. So I add this conversion, which is 1,000 milliliters over 1 liter. By doing it this way, I can cancel the liters on top and bottom, which the only thing left on this right side of the equation now is mils per hour. I multiply it across, which is 12,000 mils per 90 hours. Divide it through, gives you 133.333 mils per hour. And that becomes 133 mils per hour with our happy little red cloud. There are plenty of equations and plenty of practice in your books to be able to do that. These are just 3 ways of walking you through it to help you start practicing this. Here's another one, IV administration of fluids by gravity. So we want to calculate drips per minute, or GTTs per minute. Our problem is infuse Ceftin 1 gram in 50 mils of normal saline over 30 minutes. The tubing drip factor is 60 drips per mil. How many drips per minute will you infuse? So I have a drips per minute question, so on the left is X drips per minute. Now I need to pull the material from the top to fit into that. I have 60 drips per 1 ml. That's my first thing I start with. The next thing I have is 50 mils per 30 minutes. It's already there for us. I can cancel out those mils using the equation we talked about earlier. Now I have 60 drops, times 50 over 30 minutes. But do I need anything else? I don't, because all I have left on that right side of the equation is drips per minute. Everything else has been canceled. So I multiply across 3,000 drips per minute over 30 minutes. Divide it over, and you get 100 drips per minute with our happy red cloud. Practice these. Take a moment whenever you see me. Go to the next one. Pause the video. Take a look and see if you can do this. So let's do another drips per minute. I do 3 of these at a time. So I have He-Span 500 mils to be infused over 3 hours with a drop factor of 15 drips per mil. How many drips per minute will you infuse? Well, again, I need drips per minute, so I have X drips per minute, or drops. I'm going to pull what I have for the drips per minute. All I have is drips, so it's 15 drops per 1 ml. And then I'm going to multiply it by what I have, which is 500 mils per 3 hours. And by doing it in that manner, you see I can cross multiply the mils to cancel that. Just like that. All I have now is drips per hour. But that's not enough. We need drips per minute, correct? We need to convert it. So I have hours on the bottom. So I put 1 hour on top over 60 minutes. Well, so it's 1 hour is 60 minutes. Cancel those out. What do I have left on the right side of the equation? I have 15. I have the drips on top and the minutes on bottom. That will tell you that you have everything canceled that you need and all conversions are done. So I will multiply and divide across to give us 41.6. And you convert that to 42 drips or drops per minute. Happy little red cloud. Let's do another one. D5W, 1,000 mils is ordered to be infused over 4 hours. The drop factor tubing is 15 drips per mil. How many drops per minute should be administered to infuse this 1,000 mil bag of D5W over 4 hours? So what do I need? Drops per minute. So X drops or drips per minute. What do I have up there? Well, I have the 15 drops per 1 ml, so that's the top of the equation. And I need to get that mil canceled out. So I will pull what I have, which is the 1,000 mils over 4 hours. That's my order, so I can use that. Canceling out the mils, I have drips on top and hours on the bottom. Once again, I have to cancel those hours out, though, with a conversion, so I have drops on top and minutes on the bottom, like the left side of the equation shows. Once I cancel everything and show that I have drops on top and minutes on the bottom, that's when I know I can multiply across, divide out, and I get 62.5 drips per minute, which becomes 63 drops per minute. Again, practice these. These are showing you ways of pulling your numbers. These arrows are meant to help you find where this information is coming from. Now let's do some timed infusions. So the nurse hangs 500 mils of fluid at 1800 hours. The fluids are set in a pump to run at 250 mils. At what time should the infusion be complete? So you can have equations like this where you have to know this. The reason you have to know this is because there are some fluids where once they're up, you need to be able to make sure to go back there and continue a new bag so you know when to go back in there. So what time should the infusion be complete? We have X hours to work with first. We need to know how long. So we have 1 hour per 250 mils, which you can see up there. We put 250 mils per hour. I just put the hour on top because that's what's on the left side of the equation, so I can start canceling things out. Up there, I also have 500 mils, so I just use the 500 mils on there to use that. So by canceling that out, 250 into 500, we have 2 hours. 500 divided by 250 gives us 2 hours, okay? I add 2 hours to the original time, and that will tell me what time the infusion should be complete. So 200 hours. Let's do another one. The nurse hangs a 1 liter bag of fluid at 0900. The fluids are set on the pump to run at 125 mils per hour. What time should the infusion be completed? Okay, so again, I need to know how many hours it's going to take first and foremost. I have 1 hour per 125 mils. And as I said, the left side has X hours. I start hours on top so I can start canceling things out. I'm converting because I have a 1 liter bag. I need to see how many mils are in there. So I say, okay, 1,000 mils per 1 liter. So 1 liter as well. This is just an extra step for it, but I need to make sure this fits. I need to make sure that everything goes and converts correctly. So I'm canceling out the liters because all I need to have on top is hours. So if I left it like this, I'd say, okay, 1 hour over 1. Technically, I have 1 hour per 1 liter. I need to cancel those liters out, which means I have 8 hours when I multiply and divide across. So I take those 8 hours, add them to 0900, it becomes 1700. So the question is, what time should the infusion be completed? It'd be 1700. So now you have to be careful. The nurse hangs a 1,000 milliliter bag of fluid at 22:30. The fluids are sent on a pump to run at 80 mils per hour. How long will it take to for the infusion to complete? So I have X hours again. 1 hour over 80 mils, just like we had. I have a 1,000 mil bag. So do I have anything else left on the right side that I need to cancel? No. So I have hours. I multiply across and divide. Gives us 12.5 hours. What do I do now? Well, nothing, because the question specifically asks how long will it take to complete. I could add that 12.5 hours, but if I choose to do that, I have answered the question incorrectly, because the question only is asking for how long it will take, not the time it will complete. Now, let's move on to weight-based dosing. You're going to be introduced to this now. You have a patient who has an order for drug A to be given at 7 mils per kilogram. The patient weighs 143 pounds, and the medication is to be infused over 7 hours. So how many mils per hour will you set the pump to? This is what we have. So we have a 143-pound patient. I need to convert this to kilograms. Again, I'm going to back and forth just while you see this, but I'm going to convert this to kilograms because it's 7 mil per kilograms. And whenever you see pounds and it's a weight-based calculation, you need to change it over to kilograms. So X kilograms, this is the same as dimensional analysis. X kilograms. I have 1 kilogram over 2.2 pounds. That should be gold, but you can see that that's a conversion that you need to know. I convert that by multiplying it by the actual weight there, which is 143 pounds. Canceling it out, all I have left on the right side is the kilograms. Multiplying across gives me 65 kilograms. So the question was 7 mils per kilogram of drug A. How many mils will you give? Well, I have X mils on the left side. That was my question. 7 mils per kilogram. I need to cancel that kilogram out. So I put the 65 kilograms from earlier right there. Multiply it across. All I should have left is the mils, which I do, which gives 455 mils of drug A. How many mils per hour will I give if it's given over 5 hours? Okay, so now I have X mils per hour. Do I already have this information? I do, because I have 455 mils will be given, and my hours on the bottom are already there at 5 hours. The question is asking for mils per hour. You already have mils per hour, so nothing really needs to be done but to bring it down to 91 mils per hour. So that would be the answer to each of those, depending on what the question is asking. So let's move on to dimensional analysis, just to kind of show you the dimensional analysis for this. So if I wanted to convert absolutely everything from earlier, using this equation right here, one step at a time, I say, okay, I need X mils per hour on this information that we gave in the earlier question. 7 mils per 1 kilogram. Okay, I need to change this to mils per hour, so I need to multiply that kilogram out and cross. So now I have the conversion of 1 kilogram per 2.2 pounds. I'm like, okay, so I have 7 mils per 2.2 pounds. I have a 143-pound patient. So I take that conversion and multiply that and cancel out the pounds. So do I have mils per hour? I do not. So now I need to add those hours on the bottom. Say, okay, it's 1 over 5 hours just because I need the hours on the bottom, because on the left side of the equation I have mils per hour. So now I'm going to say, all right, if I have everything on there, which I should at 7 mils, the mils on the top and the hours on the bottom, I should have 1,001 mils over 11 hours. Gives you 91 mils per hour. This is a full dimensional analysis to make sure that you can get it all done in one step. Now let's talk about heparin. The reason I started with dosage calculation with weight-based and started introducing it to you is because heparin is one of the ones that really starts doing weight-based. They have a lot of rules. You have a lot of policies with this. You have at least 2 nurses checking your calculations with this. So when you start going through this, you have to know how to do it correctly. You have 2 calculations. You have to do a bolus. You have your drips in milliliters per hour, and your protocols are ordered in 2 steps with bolus and infusion rates. Then you have PTTs, labs that are ordered every 6 hours, and you can adjust your rate based on this. And you can even use another second bolus depending on what it is. So you have to be good at this weight-based to be able to do this correctly. So here's your standard order that can happen. Start heparin of GTT. Bolus is 70 units per kilogram. Start infusion at 17 units per kilogram per hour. drop ETT every 6 hours and adjust by scale. And then there is your dosing based on what your PTT is. If it's less than 35, you do this. If it's 55 to 85, there's no change. You have to be able to draw that and understand what the number is and then make that decision. Now on that bottom, you see that new rule. If it's heparin, you round to the nearest full unit because 4550 is very difficult to pull up correctly, but 4500 is the actual rounding rule. It would be the actual correct answer, not 4550. And again, any rules or things like this would normally be on your actual equation, and it would be in front of you when you're doing this order too. But when you start doing your test questions based on this, you'll have this in front of you. So the first thing we need is the bolus. So to start the protocol for a patient weighing 65 kilograms, the bolus is 70 units per kilogram, like the equation said. So I need the number of units to give for a bolus. So I start by saying, okay, X units is on the left. So I start with units on top, which is the 70 units per kilogram. I need to cancel those kilograms out. So I just have units left. So I bring in that 65 kilograms from the patient's weight. Cancel it out. All I have left is 4550. I round that to 4600 per the heparin rounding rules. So now I have an order for 4600 bolus of units. I have in front of me 5,000 units per mil. So I have to know how many units is in that heparin. You can have a lot of different units, so you need to look at that. So I need to know how many mils to give. So 1 mil, which is, again, on the left side of the equation, I have mils. I need to know the mils on top, and on the bottom is 5,000 units, which you can see on the bottle. And earlier we had 4,600 units that we found we needed. We cancel the units out because it's just a unit of measure, and all I have left is mils. So that gives us 0.92 mils of heparin for bolus. However, if I have a bottle with 10,000, it's the same idea, but I have to start with 10,000 on the bottom, not the 5,000. And this is extremely important for you to know. Multiply by the same number of units and cancel gives you 0.46 mils for that bolus. You have to know what you're working with because you can give the wrong dosages very easily if you're not doing this correctly. So let's move on to the infusion. On step 2, we have availability as 100 units of heparin per mil. Okay? And you can see that on the right side of that, on that actual heparin sodium, you see that 25,000 USP units per 250, or it becomes 100 units per mil, so it's there for you. The ordered dose is 17 units per kilogram per hour. And again, this is all back when we started the heparin question. So I need to know how many mils per hour to give when I'm doing the infusion. So what do I have here to actually pull? I have 1 mil per 100 units, which is up there in the available. Then I multiply that by the ordered dose, which is, again, we have 100 units on the bottom, so I need to cancel out those units, which allows me to do that. So I have 1 mil times the 17 units over 100 units times the kilograms per hour, which is already there. Cancel out the units. And now I have kilograms per hour on the bottom. I need to cancel out the kilograms. So I would use the patient's weight, which is up there at 65 kilograms. Once I put that there, it cancels that. Now I have mils on top and hours on the bottom, which is what I need to continue and finish the equation. 11.05 or 11 mils per hour to actually give the infusion. Now I've drawn my PTT. We've set everything up. We drew our PTT. The level is 36. So based on the protocol we gave, we need to give a bolus of 3 units per kilogram and increase the drips per minute by 3 units per kilogram per hour. So we're going to do an adjustment on this. So now we need a bolus and new infusion rate. You can see I left the weight here for you to see. So I have a bolus of 3 units per kilogram. How many mils do I give for a bolus, which I've set up for you? Again, mils on the left, so I start with mils on top, and I have 1,000 units you can see on the bottom with that yellow bottle. I need to pull the 3 units per kilogram so that way I can actually cancel out those units. But now I have mils on top and kilograms on the bottom. How do I cancel that out? Well, I bring in that patient's weight, which allows me to cancel out the kilograms on top and bottom. All I have left is mils. It's 195 mils over 1,000, which is 0.195 mils, which goes to a bolus of 0.2 mils. Happy little red cloud there for it. And then we want to increase the infusion rate, which is the new mils per hour, which the question is 3 units per kilograms per hour. So I need to look for the mils per hour. So where do I pull that information from? I have 1 mil, which is 100 units, which again I left on the bottom right for you to be able to see what I have. I need to cancel those units out because I want mils per hour. So I'm going to pull in from the new question 3 units per kilogram per hour, canceling that out. Now I have mils on top, but I also have kilograms per hour on the bottom. So I bring in the patient's weight again to be able to cancel it out to leave mils on top and hours on the bottom. 195 mils per 100 hours, which gives us 1.95 mils per hour, so 2 mils per hour. Increase the drip by 2 mils per hour. The original rate was 11 mils per hour, so the new rate is 13 mils per hour. It is not 2 mils per hour. The new mils per hour is now 13 because we've increased it by 2. To be able to do this, you need to practice. There's apps, there's websites, you have books, Pinterest, a lot of different places have these for you to practice with, so you need to be able to do that. This is meant for you to go home, to look at these and to practice and to start getting ideas of where you'll get these numbers. Some of these are more complicated, some of these are less, but hopefully you found it useful to you.